Welcome to this video lecture. Today we will learn network theorem easily. First we will understand what is a network. So what is a network? So it is an interconnection of circuit elements. What is circuit elements? They are active element and passive element. What are active element? These are supplies energy to the network. That is voltage source, current source. What is passive element? Is consume energy. That is resistance, inductance, capacitance. Now network element, if the network element is only the passive element, we call it network. But what is a circuit? Circuit is the interconnection of active element and passive element. Circuit is interconnection of active element and passive element. So that means if I draw different resistors are connected R1, R2, R3, R4, R5 in this manner. So we can call it a network, interconnection of passive elements. But if I connect a voltage source over here and a current source over here, so it's formed a closed loop, right? So this is a circuit. Now, what is a node? Node is interconnection of two or three circuit elements. This is node. Then what is a junction? When more than three elements are connected at a particular point, we call it junction. In the first year electrical, we will learn different theorems other than this. Thevenin theorem, Norton theorem, superposition theorem, maximum power transfer theorem. Any two-terminal network which is active, linear, bilateral. Any two-terminal active linear bilateral network can be transformed to a simple circuit which contains a voltage source and a series resistance. So what do you mean by active? Active means it must contain voltage source, current source, not necessarily single. It's multiple voltage source, multiple current source are there. What is linear? Remember that in the class 12 we already learned that V is proportional to I. This V is equal to YR. So that is the resistance, as we call a circuit element, is linear if the relation between the current and voltage involve a constant coefficient. That is, resistance R is linear. Why? Because the voltage and current relationship, it depends on a constant coefficients. Just note down. We can see V is equal to IR, and for inductance V is equal to LdIdt. For capacitor, voltage across it is equal to 1 by C Idt. So we can see this circuit's elements is linear. Why? If the relation between the current and voltage involves a constant coefficients. A linear network is one in which the principle of superposition holds. And what is bilateral? We can interchange the terminal. Like in a resistor, current can be flow in these directions or current can be flow in this direction. The result is same. So according to Thevenin's theorem, a two-terminal active linear bilateral network can be transformed to a simple circuit which contains a voltage source and a series resistance. If you see the statement is Thevenin's theorem states that any linear active two-terminal bilateral network containing resistances, one or more voltage or current sources can be replaced by a single voltage source VTH in series with the resistance RTH. VTH is known as the Thevenin's equivalent voltage, or that is the open circuit voltage at the network terminal, and RTH is the equivalent resistance of the network when all sources are replaced by their internal resistances. So that means this RTH is the equivalent resistance, this VTH is the open circuit voltage. Now, what is Norton theorem? The same thing, according to Norton theorem, any two-terminal active linear bilateral network can be transformed to a simple circuit which contains a current source and a parallel resistance. this is denoted as Rn, Norton equivalent resistance, and this is In. So this is the terminal A and this is the terminal B. Now this In is the short circuit current. In, Norton current, is the short circuit current. That is, in the Thevenin circuit, if you short it, the entire current will flow through this path. So this ISC is equal to VTH by RTH. So this is the short circuit current. And this Rn is equal to the equivalent resistance. So it will be similar to RTH. So this is the Norton theorem statement. Any two-terminal active linear bilateral network can be transformed to a simple circuit which contains a current source and a parallel resistance. See the Norton theorem statement. The same thing, Norton theorem states that any linear active two-terminal bilateral network containing resistance and one or more voltage or current sources can be replaced by a single current source In and parallel resistance RTH or Rn. In is the Norton's equivalent current, that is short circuit current, and Rn is the equivalent resistance.